Alright guys, welcome to this very quick video on transformers. I'm going to cover the basics of transformers in this video, and then in a later video there'll be one more a bit more sort of technical about kind of how transformers work and why we use them. So be sure to watch both. Okay, let's start off with what a transformer is. We can see a picture of one on the screen, and they're really simple. The way that we make them is just simply by taking a primary coil of wire, so that's the red one on the left hand side, a secondary coil of wire, also copper wire, and then a soft iron core. Okay, so by soft here, we don't mean soft in terms of touch, but soft magnetically. Okay, and that means that this will be magnetic for a short time. As long as there is a magnetic field sort of near it, then this material will become magnetic, and if the magnetic field is taken away, it will stop becoming magnetic. Now, boiled down, okay, what a transformer does is it changes the voltage. What we have is an incoming voltage, and we'll call that VP, which is the primary voltage, and an outgoing voltage, we will call that VS. Okay, that's the secondary voltage. And it turns out that what we can do is change those voltages. We can step up the voltage, going from primary to secondary, or step it down. We can increase or decrease the size. Now that's governed by an equation, which is really simple. We've got Vs over Vp, that's the ratio of the voltages, is equal simply to the ratio of N, where N is the number of turns. Okay, so literally all we're doing is taking some wire and wrapping it round our core. And if the number of wrappings round, the number of turns on the right hand side is greater than on the left hand side, then we've got what we call a step up transformer. And in other words, the voltage will increase. If, however, the number on the right hand side is lower, then we've got a step down, and that's actually what you can see on the screen here. You can see quite clearly there's lots of red turns there, okay, and there's fewer blue ones. That would mean that NS is less than NP, fewer turns on the secondary coil than on the primary coil, and that means that our voltage steps down. So it's a really amazing piece of kit, really, that works. No electrical connection, okay, simply just a conversion of the size of the voltages. Now there's something that I've not put in this video, I will in the next, is that this only works with alternating current. Okay, so that VP or that VS stands for the amplitude of our alternating current or alternating voltage. Okay, all we're going to do right now is just look at an example question and think about how we use this equation. Okay, so we might have a question like this. We have 200 turns on the primary coil and 800 on the secondary coil. So you can see we're going from 2 to 800. We already know actually that this should be a step up because we've got more turns on the right hand side on the secondary coil than we do on the primary coil. Okay, we're also told that the potential difference on the primary coil is 12 volts. And what this means is we've got an alternating voltage with amplitude 12. Okay, so the question then obviously is, what's the potential difference on the secondary coil? That's the unknown. Well, what we would do then is simply write it out. Okay, we have this equation. This is our often referred to as the turns ratio. It's our ratio of the turns. It's an equation which equates the ratio of the potentials to that turns ratio. Now, 4 pieces of information, but we know 3 of them already. Okay, we know Vs over Vp is equal to Ns over Np, which is simply 4. 800 divided by 200, which equals 4. And what this means is that my potential difference should be stepped up by a factor of 4. Okay, well, we know the input voltage, our primary voltage, is 12 volts. The ratio there must also be 4. And therefore, our Vs must be 48 volts, in other words, 4 times 12 volts, okay? And this is just how you use it. When you're given this equation, you'll usually be given 3 of the unknowns, and then you'll be asked to calculate the 4th, okay? And what I always do recommend to my students is to do a little bit of a check. We know that if Ns is greater than Np, okay, then Vs will also be greater than Vp. In other words, this is a step-up transformer. Okay, so what you need to now do is try and apply this to your own calculations, and then we'll think about in another video how the transformer works.